Oh, hi there. Thanks for showing up for your learning. Let's take a look at the exponent properties material from quite some time ago. So, making sure that we understand what an exponent means and how to evaluate one, and also some quick exponent laws and how to work with scientific notation. So let's get started, everybody. First, expanded form of an exponent looks like this. If I have something like k to the 5, that's the same thing as saying 5 copies of k which multiply one another. So this number tells me the number of copies, and that tells me what's being multiplied. So that's expanded form for k to the 5. If I have 2x in brackets to the 3, well, I would take what's in brackets and multiply it by itself 3 times, and that's expanded form in that case. I could also then simplify that and say that's 2 times 2 times 2, or 2 to the 3, x to the 3, and that's equal to 8x to the 3. But this is expanded form. That would be what we were looking for. Okay. Now, if we have stuff like this to write an exponential form, this one is 1, 2, 3, 4, 5, 6 copies of m multiplying. So this is equal to m to the power 6. And this one here is 4 copies of y multiplying, and along with 2 copies of p multiplying. So I have 1, 2, 3, 4 copies of y. This is y to the 4. And then p times p is p squared. All right, let's carry on. So, there we go. All right, for those of you that are this far along, this will be a real treat for you. So let's take a look at how we evaluate these exponents, leaving as a fraction when possible. So 7 to the 4, wow. We want to raise 7 to the power 4. I'm going to give you a calculator for that, don't worry. But that's just 7 times 7 times 7 times 7 times 7. So let's take a look at how you punch these on your calculator, because most people don't have the patience to multiply 7 4 times in their head. You do 7, then you go ahead and find this looking button. You say raise that to the, it's a lot of glare on there, right? To the 4. Then we say equals, and it's, 2401 is that one. And you can memorize these two. They're useful to memorize. But if you haven't got that ready yet, I wouldn't memorize that for the exam. All right, negative 4 to the 3. This is the same thing as saying negative and then 4 to the 3, okay? The negative doesn't come along for the exponent ride. So this is just 4 to the 3, which is 64. Your calculator will tell you the same thing, but it's negative. This is a negative 64. Negative 6 to the 4, on the other hand, this time, if I did write that out, it'd be negative 6 times negative 6 times negative 6 times another negative 6. That's 4 negatives multiplying. 4 negatives multiplying absolutely give you a positive number. So that's just 6 to the 4, but it's positive. 6 to the 3 happens to be 216. Multiply 1296. So let's see. 6 raised to the power 4 equals 1296. So that's how you do this type of question. Okay, so there's that one. Now, last one, 2 over 3 to the 3. Let's take a look at how we tackle this type of problem. Let's write it out. 2 over 3. We are going to raise this to the power 3. That will be equal to 2 over 3 multiplied by 2 over 3 multiplied by 2 over 3. Are you noticing the same thing I'm noticing? That writing things out in expanded form makes things easier. So if you're having trouble with any of these problems, use this trick to understand them better. Now we do top times top times top over bottom times bottom times bottom. Another thing I notice is that's 2 to the 3 over 3 to the 3. Very cool. That will be 8 over 27. Done, final answer. All right, so now we go back to this sheet and let's see what we've done. I think we've understood powers so far. We've used expanded form. We can write things in exponential form. We can evaluate some exponents. Okay. Now let's take a look in at our exponent laws. Remember, you want to use this sheet to check off, okay, I've got these things, I know them. I probably don't need it on my cheat sheet. Maybe if there's something that you want on your cheat sheet, maybe green means put it on your cheat sheet. You need a few examples or something like that. This way you can plan, what do I want on my cheat sheet? Make sure you don't forget something. Don't forget something. Okay, now simplify the following expressions using exponent rules. All right, if I've got x to the 4 times x to the 7, I could write them in both in expanded form. I'd have 4 copies of x multiplying here, 7 copies of x multiplying there, a total of 11 copies of x multiplying. Add the exponents. When multiplying powers of the same base, add the exponents. This is x to the 4 plus 7. This is equal to x to the 11. V to the 4 to the 9. Okay, I can expand this as well. That would be v to the 4 multiplied by v to the 4 multiplied by v to the 4 dot dot dot. 9 such copies of v to the 4. So in this case, I'd have 9 4s to add together. Another way to do that is multiplication. In these cases, multiply the exponents. This is v to the 4 times 9. This is equal to v to the 36. Okay. When dividing powers of the same base, a to the 7 divided by a to the 3. Here, we could use expanded form again to remind ourselves of these. I'm going to do this one. This is one I have the appetite to do. Okay? A to the 7 divided by a to the 3 is equal to a times a times a times a times a times a times a. That is the correct number of a's. Divided by a times a times a. Mr. Jennings, I can see you're reaching for your cancellation pen. I know you love to use that pen. Look at that. Every one that was on the bottom subtracted one from the top. So when you're dividing powers of the same base, you subtract. Subtract the exponents. So a to the 7 over a to the 3, this is equal to a to the 7 minus 3. This is equal to a to the 4. Wait, I thought you had something else over there. No, I didn't. Look. A to the 1, 2, 3, 4. 4 copies of a multiplying. Same. Let's go. All right. This one. Oh my goodness. It's all the rules at once. Well, let's not rush. Take our time. So we'll write it out this way. B to the 2 to the 8. B to the 2 times b to the 8, all raised to the power 3, divided by b to the 3. Oh, but wait, sorry, those brackets go all the way around. That means I need to do everything inside the brackets first. So let's do the multiply first. B to the 2 times b to the 8, that's going to be b to the 10, divided by b to the 3, all raised to the power 3. All I've done is this one and this one. Now let's do this division, because it's still inside the brackets. B to the 10 divided by b to the 3. Well, that is b to the 7, 10 minus 3. But I have to raise that to the power 3. Okay, so that's equal to b to the 21, because 7 times 3 is 21. So this is b to the 21. X to the minus 4 times x to the minus 3. But the answer should only have positive exponents. Oh my goodness. Well, let's first start with our exponent laws. This is going to be add the exponents together, so that's equal to x to the negative 7. And the role of that negative exponent is says, if you're living upstairs, go live downstairs. This is x to the negative 7 over 1. Downstairs is living a lonely 1. But it needs some company because there's a negative exponent on the top, so it should go to the bottom. So this is equal to 1 over x to the 7. The negative exponent has been done. The whole thing now lives in the basement. That's done, final answer. All right, here. Let's zoom in on this one. I don't want to write it out again. Oh, I can't fit it. I'm too zoomed in. I'll move over this way. There we go. 14x squared y to the 15 over 7 x to the 5 y to the 7. Okay. First, 14 and 7 share factors. That just leaves a 2 there. Okay, 14 divided by 7 is 2. So I'm going to cancel the factor 7. Okay, so this is equal to 2x to the 2 minus 5. Okay, I do this exponent to the 2 minus that exponent to the 5. So x to the 2 minus 5, y to the 15, y to the 7. So that's going to be y to the 15 minus 7. Okay, let's go. This is 2x to the minus 3, y to the 8. But I only have positive exponents in these answers, so I better kick this x downstairs. So this is equal to 2y to the 8, all divided by x to the 3. Send that x to the 3, make it live downstairs, and make the exponent positive. Let's just work with your negative exponents efficiently. And that's done. Final answer. This one here. This is just a multiplication, okay? So we're going to multiply what we can. 3 times 2, that's equal to 6. X times x to the 3, that's x to the 1, by the way. So that's x to the 1 plus 3. And then y to the 2 plus 5. Add those exponents as well. Okay? Only the exponents with the same base, however. So now we're going to have this is equal to 6x to the 4, y to the 7. And now the biggest, nastiest looking one. Let me find a little base of blank paper over here. Copy this out for you. Oh, I lost it. There it is. Now you can see it. Okay. Let's go. So this is c to the 3, h to the 9, y to the 15, blah, 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 all over blah, blah, all raised to the power 0. Anything to the 0 is 1. Okay? Watch. 3 to the 7 divided by 3 to the 7. Well, we know something divided by itself is 1, right? If I use my exponent laws, that's 3 to the 7 minus 7. That's 3 to the 0. That's 1. So you can think about something to the 0 as being like that base divided by itself. It's just 1. It just goes away. It's gone. It's 1. Cool. Equals 1. All right. So now we have done a lot of review of our exponent laws. So we're going to flip back over to this page. We're pretty good with our exponent laws. We had a chance to review the power law, the product of powers, the quotient of powers, the powers of powers, and the zero exponent. We've worked with negative exponents. We're getting comfortable with all those things. We're ready to advance to grade 10 math. Our exponent laws. Cool. Now, working with negative exponents, we did some of that. And now, let's look at scientific notation. Write each of the following in scientific notation. Well, I know I start with the decimal place there. I'm going to move it 3, 6, 7 times to get the decimal place behind the first digit. So that's equal to 3.5 times, don't forget to write 10. That's very important. Okay? 10 raised to the power 7. Okay? 10 raised to the power 7 is the number that moves the decimal place that many times. The answer is not 3.5 to the 7. That is a much smaller number. Okay, over here, this one, I see I want to move the decimal place 3, 6, 7 times again. So this is 8.9 times 10 to the negative 7. Okay, I would divide by 7 copies of 10 to take the number 8.9 and turn it into 0.6 zeros with an 8, 9. So you divide by 7 tenths. That's why we have to the negative 7. Okay, let's keep going. All right, and then when you read these, you'll notice this number here tells you how many times to move the decimal place to the left to get it back over there. And this one, well, it's a negative number. It tells you how many you're going to move this decimal place to the right this way to recreate this big number. Okay, so you'd have 3.5, and you move the decimal place 7 spaces that way. So you need some zeros to fill that in for 1, 2, 3, 4, 5, 6, 7 moves. Okay, with this one, you'd have 8.9, and you move it 7 that way. So we need some zeros. 1, 2, 3, 4, 5, 6. There it is, 7. Okay, add the front 0 for clarity. Cool. All right. So here we're going to move. Oh, I notice this is negative. So I'm making this number really small. I move it that way. So let's go. 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be 11 moves from here over to there. And you could count them. Check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're good. We're good. Over here, 7.8 times 10 to the 6. 7, 8. That's 1, 2, 3, 4, 5, 6. Pyong, 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 pyong. And then you could put in your little commas to make that very clear. 7,800,000. Cool. So that's writing things in standard form, writing things in scientific notation. Now, when you're evaluating numbers with scientific notation, there are some nice shortcuts available. Or you can just button mash on your calculator and do it correctly. Okay, so you want to have both skills because one you could use to test the other. 2.5 times 10 to the 5 equals that number. Okay, times. This means multiply. 1.8 times 10 to the 3 equals there, that number. 450 billion. 450 billion. But I'm going to write that in scientific notation. 4.5. And I count my decimal moves. 3, 6, 7, 8. Okay? What if I told you there was an easier way than just button mashing your calculator? Okay? It's this. You're going to pull out a different color pen so you can show the different type of work. You're going to remember that multiplication can be done in any order. So I'm going to do, so this is correct, but I'm going to do 2.5 times 1.8 times 10 to the 5 times 10 to the 3. Here I have exponents with the same base, so that's 10 to the 8. And 2 to the 5 times 1.8, well, it would be 4.5. That's 4.5. How did I know? Well, I did 1.8 times 2, which is 3.6, and then I added half of 1.8, which is 0.9, so it's like 9 times 5 divided by 10, 4.5. Okay, so there you go, 4.5 times 10 to the 8. So that's how I would do it in my head. Okay. Do both ways to check. Make sure your answer is correct. Okay, over here, 6.8 times 10 to the 3 divided by 2.5 times 10 to the minus 4. So here, I would do this as 6.8 divided by 2.5. I'm going to get a decimal there. I don't mind a decimal in this case. Times 10 to the 3 minus 4. Okay? When dividing powers of the same base, you add the exponents. Okay, so that's equal to 6.8 divided by 2.5 is equal to 2.72. Cool. 2.72 times 10 to the 7. 3 minus 4, that's 7. So 10 to the 7 then. And then you can check your answer. Here's a way that you'll want, something that you'll want to do to check your answer in this case. 6.8 times 10 to the 3 divided by, put everything in your denominator in brackets on your calculator. Use the brackets there. 2.5. You don't want to end up multiplying by this 10 to the negative 4. You want to divide by it because it's on the bottom. 2.5 times 10 to the negative 4. And the bracket equals, oh, look at that. 1, 2, 3, 4, 5, 6, 7 moves with the decimal. I'm correct. That's correct. Here, 2.2 times 10 to the 2 to the 5. Okay. Here, this is a variation of, we saw it up here, this idea. 2x all to the 3 is those three things multiplying, so that's 2 to the 3, x to the 3. So a generalized form is ab raised to the x is equal to a to the x, b to the x. Let's see how that applies down here. So this is equal to 2.2 to the 5 multiplied by 10 to the 2 times 5. So that's 2.2 to the 5, some number in the 50s somewhere, I think someone told me, raised to the power 5 is equal to 51.53632. 51.53632 times 10 to the 10. Okay, but I want to get this in proper scientific notation. So I'm going to move this once that way. So I'm basically dividing by 10, so I'm going to multiply by an extra 10 when I do that. So this is final answer equal to 5.15363 times 10 to the 11. But Mr. Jennings, shouldn't I round that? Nah, just leave it as 100% accurate. Why would you want to round when you can be perfectly accurate?
Mr. Jennings.
Yeah?
I got that one wrong, but I can tell you got it after.
Okay, cool. You multiplied by 5 somewhere?
I just have 5.15, but I don't have anything after that.
Oh no, it's very definitely times 10 to the 11. It's a huge number. It's not
Oh
small.
no, I have 5.15 times 10 to the 11. I just don't have 3632. Is that okay? No?
As I was just saying, why round? Just leave it as perfectly accurate. So I would just keep all the accuracy there and write down the whole thing.
I didn't take anything off. It's just what I got for some reason.
Maybe your calculator foiled you or something. 2.2 to the 5 feels like it should have 5 decimal places. Okay, and then the last question. Oh, here we want to know if we wanted to create a pile of goldfish that had the same weight as a blue whale, how many goldfish would be in such a pile? Okay, with these types of questions, I normally say visualize, but I think even the visualization of this situation will be a biohazard. So be very careful with what you imagine. Sometimes the things you imagine will come true. Okay, so I don't think in this case it will come true. All right, so now we want to know how many goldfish in a blue whale. So here we have a blue whale divides into how many goldfish? Okay, this is tiny down here. This is big up here. When you divide something big by something tiny, you get big number. Okay, so that's going to work for what we're looking for. So now put the numbers in there. 3.0 times 10 to the 5 divided by 2.0 times 10 to the negative 1. Okay, all right, 3 divided by 2 is 1.5. 10 to the 5 divided by 10 to the negative 1 is 10 to the 5 minus 1, which is 10 to the 6. There. Therefore, 1.5 million goldfish weigh as much as a blue whale. And that's a super fun factoid to now put into your brain. All right, so these are all the skills, tips, and tricks. I think that's a fairly big goldfish. Not a huge one. Some goldfish could weigh a kilogram. Anyway, all of these tips and tricks will certainly help you on the exam. Then you want to last bit, come back here and say, yes, I have done some scientific notation. Yes, I can apply scientific notation to various problems. And you should be pretty well ready for that. Any questions, hit me up by email. Otherwise, thank you for showing up for your learning.